Thank you very much. Good morning, ladies and gentlemen. I'm very glad to be here in this beautiful city of Rijeka, and I'm glad to participate to this scientific event. Thank you for the kind invitation I got from Mr. Ernst Kukrov and from Dr. Sven Maricic. I'll try to present briefly some of the experience we have in Cluj-Napoca. Cluj-Napoca, it's quite a big city in Transylvania, and if you are to ever visit Cluj-Napoca, please don't hesitate to see our botanic garden. We don't do just technique in Cluj-Napoca. We started many years ago from the very bottom level, 30 years ago in mechanical engineering, and about 20 years ago we moved to 3D printing or additive manufacturing or rapid prototyping. These new technologies are opening amazing opportunities both for industrial applications and for medical applications. We started with some simple 3D printers, and then we moved to 3D printing of plastic. It's a bit easier, and the equipment now are not expensive, but when it comes for 3D printing in metal, then both the equipment are more sophisticated and more expensive, and also the technologies require a higher experience. If someone is interested in 3D printing, then Wooler's report is a very good literature where you could find all the suppliers of the equipment, all the suppliers of the materials, and also a lot of case studies in different countries. And when a company begins a new application in 3D printing, then within the Wooler's report, which appears every year, you could see which are more suitable technologies for your application. This is, well, I won't go into details because I think that quite many of you are aware of these technologies. We started 20 years ago with this LOM 3D printing technology, then with Stratasys technology. You can imagine how fast the technologies are advances and how fast the cost of equipment are going down. For example, for this machine, I paid more than $100,000 20 years ago, and today you could buy it for probably 1,500 euros. So this is the very good news for new applications, because the equipment will become more and more available. One of the very good technologies is this one, selective laser sintering. So onto this machine we could produce parts from different materials. All the materials are in a powder shape. It could be plastic powder, metal powder, and using this technology, for example, we could produce directly active tools for injection molding. So in this case, the time to develop a new product decreases a lot. Sorry for the Romanian words in this movie, but what I want to emphasize, could we make the volume a bit slower? Sorry. Yeah. What I want to say is that with these new technologies, we are not able to print only separate components. We could print directly a product which could be designed in a different manner. So the whole design paradigm changes. You don't design something which would be assembled using screws and nuts. For example, this product has 9 components, and it has been produced in our department just as one piece, a functional one. This is the best machine we have. It is a selective laser melting machine. Onto this machine we could produce directly a stainless steel part, a tool steel part, if it's a medical application, a titanium component, and which is more important is the fact that it's a fully dense metal part. So the mechanical properties are as good as if the part would have been made using classical technologies starting from a laminated material. So a complex part like this one could be made in stainless steel directly, well, not in a few minutes, but not even in a few hours, perhaps in 2 or 3 days. So that's why the rapid prototyping name has been changed to additive manufacturing, because, for example, to produce a part like this, it took 72 hours. So please don't think that 3D printing it's as simple as you just push a button and you get it printed. So it does require experience. For example, all these components for a hydropower plant have been manufactured in my department using the 3D printing technologies, and the material was stainless steel powder. Other parts made from different materials. And okay, I want to say something more. Rapid prototyping, rapid tooling are very good, but the well-known CNC machining technologies will keep be in the future also an alternative, because, for example, we got an order to produce a very complex part like this, and sometimes what we need to do is to combine the 3D printing technologies with classical technologies. So a part like this with complex cavities from here cannot be made using just 3D printing, because the supports would be strongly welded inside the cavities, and it's almost impossible to be removed. 3D printing is good when it's about just one single prototype. When a company needs 30 or 50 parts, then silicon rubber molding, it's a very good rapid tooling solution, and we use this technology quite often, mainly for producing plastic parts with a complex shape in a limited number of parts. Metal spray tooling, it's also a very good rapid tooling technology for a medium volume production. So if the order is not 50 parts, if it's 1,000, then we have this metal spray tooling technology, which allows us that in 2 or 3 days we could produce the molds. Investment casting, it's another good technology for aluminum components. So if a metal part has a very complex shape, and if it's hard to find a splitting line to open the molds, then investment casting, it's a good technology. So for example, we use in my department this equipment, which has a vacuum chamber, an induction oven, and we used 3D printing just to produce master models, and then at the beginning we set up the wax tree and then the metal. So a very, very complex, even such a figurine which has very complex shape could be produced in 2 or 3 days. As I was saying before, 3D printing technologies are very good, but they cannot be used just as standalone technologies without other suitable technologies. For example, EDM wire cutting, this equipment, it's very good, and it allows us to produce very rapidly and very accurately parts like this with a very thin wire brass. We could cut in a thick and hard block of metal. Water jet cutting and water jet milling, it's also a very good technology that we have in our department, and it allows us sometime to sort out issues. I was speaking quickly about many different technologies. please don't ask me which of them is better, because each of them is suitable for a particular application. We really need to look which is the material the part is made from, how complex the shape is, and how many parts you need. And only then we could choose the appropriate technologies. Well, in my department, we produce knowledge using these technologies, but obviously our main purpose is to teach our students, and we like to put our students at work, and we like to involve them. For example, for the project diploma, our students are involved both in design and also in manufacturing this kind of very simple electrical vehicles, which were entirely designed and manufactured by the students. So this short movie was recorded in the main lobby in our university in the day when this student was presenting his project work diploma. With our students, for their project work, we design and manufacture different kind of 3D printers as project diploma. Rizvan, my colleague, is here in the room, and he was working for such a 3D printer. We try to teach our students both how to design them, how to use them, and how to make them cost effectively. Some printers have a totally different way of guiding the extruder. I won't go into details because I want to show you that besides this, okay, interesting, but one might say that it's less scientific. We've been involved in a very big project and we produced quite many components for a Formula 1 car. I'm proud to say that this project, which we had 2 years ago, was our biggest project we had ever in my department, when we managed not only to produce many components of Formula 1 car, but this Formula 1 car was assembled in my department. Well, not the gearbox and the engine, they were made in Germany, but all the body panels were manufactured, and all the televisions from Romania for about 1 week were coming there, and they were interviewing, because the machine that you see here, it was the first one assembled in Romania, not only in our department. So that's why I was very proud of. So this machine that you see here, all the body car panels were made from composite materials, carbon fiber composite materials, and we produced them using 3D printing, master models, and other rapid tooling facilities that we have. Just a few words about medical applications, because these amazing technologies are very good not only for industry, but it would be a pity not to try to use them to improve the medical healthcare in our city. So what we do, for example, for this patient, he had to go through a surgical operation, and now you see, for example, probably the image from CT shows better. This is the image before the operation, and even if it's got a different gray color, the implant, but it worked very fine. So what I want to say is that what we do, it's not just theory. All the images I've presented today were made in our department, so none of them is downloaded from the internet. All this in our city, in Cluj, more than 60 people went through surgical operations, and the implants made by 3D printing in our department were used for these patients. And I want to underline the fact that it's not very simple. So it's not just that we take the image from the computer tomograph and put it in the 3D printer and push a button and that's it. Unfortunately, the media sometimes looks in a very simple way to what we do, but it's a lot of engineering work. For example, we try to do the implants. What you see in yellow are mechanical properties of the cortical bone, and with green are mechanical properties of the implant, if it's a titanium implant. So the way we work is we personalize the implants not only with respect to the shape. The shape comes from a CT, but we do need to make the implant with very close properties to the cortical bone. Unfortunately, when a person grows old, the density of the bone decreases. So that's why we need to do a lot of research how to provide suitable properties, and we've manufactured onto our 3D printing selective laser melting machine thousands of parts, and basically the implant we produce is not with a fully dense, it's not fully dense, and it's with controlled porosity, and we infiltrate. Well, you see, it looks like 3D welding, this selective laser melting, but what I can tell you is that even if you see that it goes continuously, the laser beam, we could control the point distance, so the laser goes, then stays for about 20 microseconds, so the exposure time. All these technological parameters are extremely important, and only with them one could produce a fully personalized implant. For example, if it's a hip implant, we want the implant to be with full density onto the outer, the green shape, and the more it goes into the trabecular zone, the higher the porosity, and in that area, the medical doctors will infiltrate the implant with bioactive glasses. So we do the implants not only biocompatible but bioactive as well, so that once they are implanted, then the bone will regenerate quicker. Thank you very much. I'm sorry I had to go as a quick run through what we do, but I wanted to leave some time for questions, if there might be.
Or we will continue on our round table. Nastavit ćemo sa pitanjima na našem okruglom stolu koji će biti poslije. Thank you very much, Professor Bulc. It was a pleasure seeing your lecture.